Today we're graphing quadratic functions using x-intercepts. This is often called intercept form or factored form. So that factoring, I told you, it comes back, man. So this form where it's ax squared plus bx plus c, like where we used to use the quadratic formula like that, or factor it, that's called standard form. Eventually we will graph in that form as well. But this U-shaped graph is called a parabola, that U-shaped curved line. The lowest and highest point is called the vertex. So that's going to be like one of the first points we find. It's a very important point. And the axis of symmetry is a vertical line through the vertex. It perfectly splits the graph right down the middle when you are finding that axis of symmetry. So a quadratic is in intercept form when it is factored completely. The x-intercepts, or zeros, are where the graph crosses the x-axis. All right. And the axis of symmetry is halfway in between those. So we're going to find the middle between the two zeros, and that's going to be the x-coordinate of our vertex. And I'll show you then how we would find the y value. It says right here, then plug that number back into x for solve for y. You got the blanks, pause it here, get them down, and then let's actually get after it, and you'll see all this come out into play. But find the x-intercepts and the vertex. So the x-intercepts come from solving it out. If you look at this, if we were just solving this equals 0, you would set up an equation every time you see a k. So you would set up, like the 4 on the outside doesn't matter when you're finding the intercepts, but we would set up like k plus 5 equals 0 and k minus 1 equals 0. So to solve k plus 5, you would subtract 5, and you get an x-intercept or a 0 at negative 5, which means if we were to graph it, it would cross the x-axis at negative 5. Also, over here, if we add 1 to both sides, it's going to cross at positive 1. So our zeros are negative 5 and 1. Or sometimes they might list them as coordinates, like negative 5, 0, and 1, 0. I honestly don't care either way, unless it has like, write it as a coordinate, then write it this way, but otherwise I don't really care. So as far as finding the vertex now, you need to find the middle of those two values for x. Well, these are k's, it doesn't matter. So if you can't figure out in your head what's in the middle of negative 5 and 1, when you do like mean, median, mode and stuff and you're finding the middle, you can always just add them together and then divide by 2, and that'll find the middle for you. So this will be, we'll call it x equals, because this would be the x-coordinate of our vertex. So negative 5 plus 1 is negative 4, divided by 2 is negative 2. So when we are finding our vertex here, the x-coordinate of the vertex, which in this case is negative 2, is also the axis of symmetry. It's that vertical line that splits the graph perfectly in half. Now, how do you find the y-coordinate? You plug in negative 2 into the original equation and you solve it out. So we'll say f of negative 2, that's just function notation. So this means we're putting in a negative 2. I'm pretty sure those were supposed to be x's if we have f of x over here. So we have 4 times, in parentheses, again, we're substituting in negative 2 for these k's. So negative 2 plus 5, and then negative 2 minus 1. So give us 4 times 3 times negative 3. So 4 times 3 is 12, times negative 3 is negative 36. So this becomes the y-coordinate of the vertex. Whew, a lot of new stuff there. A lot of it. But this all comes into play when we are graphing. So let's try example 2. This one's not in factored form, so we're going to have to do that first. Can you think of factors of 10 that add up to 7? 5 and 2. So this would factor to, let's see, f of x equals x plus 5 times x plus 2. Now we've done so many of these at this point, I'm fine with you actually just writing the answer for once you have it factored. Look, when it was k plus 5, your answer came out to negative 5. K minus 1 came out to positive 1. It's always the opposite of what is grouped with the x. So this says x plus 5. That means our x is going to come out to negative 5. right? Because negative 5 plus 5 is 0. x minus 2, that means x is going to come out to negative 2. So we're going to have zeros. I forget if there's an e or not on zeros. I don't think there is. Oops. So there's zeros at negative 5 and negative 2. Great. So if we were graphing, we could put an intersecting point at negative 5 and negative 2. And we would know that our parabola is going to cross through those points. Now, to find the vertex, we have to find the middle of those two. So we're going to say this is for the axis of symmetry. We just add the zeros up and divide by 2. So we're going to do negative 5 plus negative 2 and divide it by 2. This would give us negative 7 over 2, which is negative 3.5. So for our vertex, this gives us the x-coordinate, negative 3.5. To figure out the y of the vertex, this is where we have to substitute that negative 3.5 back in and solve it. Now, it doesn't matter if you go with the original equation or the factored equation. It works out the same way. Let's just go with the factored equation. So we're going to be putting in negative 3.5 in for those x's. So we'll have negative 3.5 plus 5 times negative 3.5 plus 2. This comes out to 1.5 times negative 1.5, which I believe is negative 2.25. So that would be the y-coordinate. Now we're going to be graphing these next. So you're going to want to find the intercepts, mark them on the x-axis, and then you're going to plot your vertex, negative 3.5, negative 2.25, which would be right here, and then you can just draw your parabola through those points. It's not too bad. So let's get after it. Here we go. This one, they factored it for us. They're so sweet like that. But our x-intercepts, our zeros, remember, come from this. It says x plus 1. So that means we're going to have an x-intercept at negative 1. And again, you could just write negative 1 or write it as a coordinate, negative 1, 0. Also, this one says x plus 5. That means we're going to have one at negative 5. So go ahead and give yourself dots on the graph at those coordinates, negative 1, 0 and negative 5, 0. Now you can figure out with your brain, because you're super smart, what's in the middle of negative 1 and negative 5 would be negative 3. That is what it's going to work out to be, but it's not always super easy to see that. So again, you can figure out your axis of symmetry. You just say x equals, you add up the two zeros, negative 1 plus negative 5, and divide it by 2. This will give us negative 6 over 2, which is negative 3. Now, when I'm really graphing these myself, I like to put a vertical imaginary line, just like a dotted line, for the axis of symmetry. Because again, it should look exactly the same on both halves of that. But that coordinate, the negative 3, becomes the x-coordinate of our vertex. To figure out the y, you substitute this back in and solve it. So we're going to put in negative 3 there for the x's. So we'll have y equals negative 3 plus 1 times negative 3 plus 5. This will give us negative 2 times positive 2, which is 4. So our vertex would be at negative 3. That seems goofy. Oh, negative 2 times 2 is negative 4. Whew, that was close. So negative 3, negative 4 would be here. And then you'll see the 3 points. It doesn't form a triangle. It doesn't form a V like an absolute value. It makes that U-shaped graph. So make it curve out and over. Now, if you actually needed to get more points on there, you could choose other numbers to put in for x, solve it, and get a corresponding y-coordinate. And then you could reflect it across the axis of symmetry. It's a little beyond where we need to be today, but it might be something we do in the future. There's one for you to try here. It's all factored up. I'm not really going to talk through this one, but feel free to try this one out here. All right, x minus 2, that means it's going to be a positive 2. X plus 4, that would be negative 4. Symmetry. equals 2 plus negative 4 over 2, negative 2 over 2, which is negative 1, which is the x-coordinate of the vertex. We'll plug that in for x, f of negative 1. This gives us negative 3 times 3, which is negative 9. Negative 1, negative 9. And then we'll draw our parabola. Whee! Do the best that we can to draw the curvy parabola. That was fun. What else we got? Oh my gosh, we have to factor this one, and then you're going to try. So now I have to think, oh dear, what factors of 3 add up to 4? 1 and 3. So we'd have f of x equals x plus 1. Come on. There we go. Times x plus 3. Remember, the zeros are going to come out looking the opposite. So x plus 1, we're going to have x equals negative 1. X plus 3, we're going to get negative 3. So those are our two zeros. Negative 1, 0 and negative 3, 0. And again, you could just say negative 1 and negative 3. Here's negative 3. Here's negative 1. We do have to find the middle, which we can see is negative 2. But we're going to pretend like we just can't see that. Our axis of symmetry, we're going to add the two zeros together and divide by 2. So negative 1 plus negative 3 over 2 will give us negative 4 over 2, which is negative 2. That's going to be our axis of symmetry. Split that graph in half. It's also the x-coordinate of our vertex. Now to figure out the y-coordinate, put it back in. You could go with the original, you could go with factored form. I think before we did it in factored form, let's go original on this one. Be wild. F of negative 2. So we'd have negative 2 squared plus 4 times negative 2 plus 3. When you square anything, it comes out positive. So negative 2 squared is positive 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4, plus 3 is negative 1. That becomes the y-coordinate of our vertex. Negative 2, negative 1. We're ready to draw our parabola, baby! Draw your parabola, draw your parabola. Look at us having fun. Cool. There's one more for you to try. Go ahead and try it. See how you do. I'm going to get ripping on it. These are our intercepts. Symmetry, x equals negative 5 plus 2 over 2. Negative 3 over 2, which is negative 1.5. Probably about here-ish. Now we'll plug in our negative 1.5. Let's see. Negative 1.5 plus 5. Negative 1.5 minus 2, 3.5 times negative 3.5. I don't know what that is. 12.25 maybe? 3.5. All right. Negative 12.25. Now that's going to actually fall off of our graph. You could always change the scale, but let's just say it just makes it down here, and then we could draw in the parabola from there. Very fun. Look at us graphing in factored intercept form.